Alright, welcome to the night class. Today we're going to be doing lesson 7-2. It's going to be fun. Last section we added and subtracted polynomials. This section we are going to multiply and divide polynomials. Actually, we're not even going to divide. We're just multiplying today. So, our first example, we are going to multiply a monomial. What's a monomial again? One term. And a trinomial, which would be how many terms? Three terms. Okay? So, I'll try to kind of review and write at the same time. Let me see here. Draw. So, negative 4x to the third. What kind of monomial is that? When it's to the third, when your degree is 3, what is it?
Cubic monomial.
It is a cubic. Okay? Trinomial is how many terms it has. Linear, quadratic, cubic is your degree. Everybody with me? Okay? Sorry?
Linear?
1 is linear. Yeah. If the exponent is 1, y equals mx plus b, it's linear. Okay? So, this is a what type?
Trinomial.
It is a trinomial, but what type of trinomial?
Quadratic.
Quadratic. Highest exponent is 2. That is your degree. Alright? You basically just do the distributive property. Negative 4 times 1. Everybody understand why I'm saying 1 there? Negative 4 times 1 is?
Negative 4.
And then x cubed times x squared. Make sure you know your exponent rules. What do you do with the exponents when the bases are the same? Add. So 3 plus 2 is?
5.
X to the 5th. Negative 4x to the third times 3x. Negative 4 times 3 is?
Negative 12.
X cubed times x? X to the 4th. Then negative 4 x to the third times negative 4. Negative 4 times negative 4 is positive 16, and then we just have x to the third.
Wait, whoa, that was kind of easy. That's what.
It is.
Wait,
Okay?
hold on. I take it back. It's 3, if that's 1, no, wait, okay. That makes sense.
Okay?
Don't know.
This would be a 5th degree. Okay? That is called a quintic, but you don't have to know that. Okay? It's a 5th degree, and it's still a what? How many terms do I have?
3. So
Still a trinomial. Any questions? All right.
So that's all you're going to do?
Yes, ma'am.
It's a trinomial?
Yes. So, try these real quick. Negative 2x squared times x squared. What would that be?
Negative 2x.
All right. Negative 2x squared times 3x.
Negative 6x.
And negative 2x squared times 4.
Negative 8 squared.
Negative 8x squared. Done. Everybody okay? Same thing down here. Let me scroll up a little bit so I don't have to bend over. Negative 4x times 2x squared.
Negative 8x third.
Good. Negative 4x squared times, or excuse me, negative 4x times negative 3x. Positive 12x squared. Negative 4x times 5.
Negative 20x. Wait, how did you get
Here, x times x squared. X is, the degree on an x is 1. So 1 plus 2 is 3. Okay? Everybody good?
Yes.
All right. That's a, says use a table to find the product of polynomials. This is just another way of doing it. Have y'all done Punnett squares in science? Okay. So, this is kind of the same thing, okay? It's not exactly, and I don't do it this way, but some people could if you wanted to, but you don't have to. So let's just say the book uses, and this is page 268, the book uses 15 and 18. So say we're doing 15 times 18. Now, most people can't do that in their head. I'm one of them. I could really think about it and figure it out. But here's what they're saying. You can make a Punnett square, okay? And this would be the same as 10 plus 5, right? And this would be the same as 10 plus 8, right? Okay? So 10 times 10?
100.
It would go there. 10 times 5?
50.
10 times 8? And 40. And then add those up. So that's 120, right? Plus 100 would be 220. Plus 50 would be 207. Okay? I agree. But they're making you do it with numbers first. Okay? And then we talk about you can do it with letters. Okay? You good?
Yeah, we're good.
Okay. So here, same thing. Okay? But you could do it like it's a Punnett square. So we have 2x and 1. Over here we got x and 3. 2x times x is 2x squared. 2x times 3, 6x. X times 1, 3 times 1. Add your like terms in the middle. So my final answer would be 2x squared. X and 6x make what? 7x plus 3. It's just giving you another tool in your toolbox. Okay? Now, do I do it like this? No. Okay? I distribute twice. All right? So, these are, what are these called? Not a monomial, but what? Binomial. These would be binomials because this is basically x plus 3, and this is basically 2x plus 1, right? Okay? So you just multiply them out. So these are, again, same thing. We'll do it the distributed way in a minute, but all you're doing is making, I don't know, that's ugly. Can't even find room to do it. Let's see it. So we'll have 2x and 4 and 5x and 2. And I can't tell you, a lot of people have to do it this way. Okay? It's easier for them. So 5x and 2x make 10x squared. 4 and 5x, 20x. 2x and times 2 is 4x and 8. Add them together. 10x squared. 20 plus 4 is 24x plus 8. Okay? Any questions? Everybody good? I'll save the other one. X times x is x squared. Okay, is that you? That's that? Okay. Everybody good? Here's, yes, sir.
So why did that, if you multiply two full numbers, why is it not squared?
Because it's not the same number. 5 times 5 is 5 squared. Right?
Yes, sir.
See, x and x are the same. So x times x is x squared. That making sense?
That does.
So 5 times 2 is not squared because 5 and 2 aren't the same. Okay?
Okay.
So here, notice it says do the distributive property. And by the way, on your homework, if it says do the table, you don't have to because you can do it whichever way. I want you to do it whichever way you're more comfortable with. Okay? But just know the other way does exist. Okay? And so here we have a binomial times another binomial. Okay? Some teachers like to refer to this as the FOIL method. Okay? I don't really like it because the FOIL method only works for a binomial times a binomial. Okay? If you're doing a binomial times a trinomial, FOIL doesn't work because there's too many things going on. Okay? But if you think distributive property, it does work, because I want you to understand that's what we're doing here. We're taking 2x and multiplying it by x minus 5, and then we're taking 4 and multiplying it by x minus 5. And we're taking those answers and doing what? Combining them, okay? So this would be 2x squared minus 10x, and this one is 4x minus 20, and then we add those up. So 2x squared minus 6x minus 20. Okay? It's very simple. And that you can do this with however many, you could do a trinomial times a trinomial. Okay? The only difference would be you would have 3 of them that you're multiplying. All you got to remember is I have to distribute everything to everything. Okay? That's all you're doing there. Now, they call it FOIL because y'all remember what these stand for?
First, outside, inside, last.
First, outside. She's been waiting for me to ask that.
Yes, I have.
Inside and last. Now, what they're talking about is the first term of each binomial. So what's the first terms of this binomial? 2x and x. Okay, these would be the first two. All right. The outside terms are 2x and negative 5. The inside terms are 4 and x. And then the last terms are 4 and negative 5. Okay? Again, if you want to do it that way, you can. But it's only good for a binomial times a binomial.
Okay, wait.
Okay?
So you're saying distributive property can only be used for a binomial and a binomial?
No.
That is the exact opposite of what I'm saying. I'm saying FOIL can only be used for a binomial times a binomial.
Like, I was never planning to use FOIL.
Okay, yeah, that's why I don't like referring to it as FOIL, because when you get a binomial times a trinomial and you start FOILing it, there's not enough letters. Okay, so it doesn't work. There's too many inside numbers.
So you're saying FOIL and distributive property are two different things in this situation?
They are exactly the same thing in this situation. It's just, when you think distributive property, that will work on bigger problems. Okay? FOIL only works on binomial times binomial. Okay? All right, so let's try these. I'm not going to write it out. I'm just going to do it. I always make the little moon. I like calling it a little moon because it looks like a little moon. Okay? I'll show you. So I'm going red this time. 5x times 2x is 10x squared. 5x times 1. Anything else to multiply that by? Nope. So now I go to the negative 4. Negative 4 times 2x. Negative 8x. Negative 4 times 1. I guess it could be like the little Costa sign. Backwards. You see that? Anyway, all right. Now, all you have to do is make sure after you do this is you combine like terms. Y'all see why it's important to do the first lesson first, and now we're doing this one? Okay. So what's my like terms? 5x and negative x. What does that make? Negative 3x. So my final answer is 10x squared minus 3x minus 4. Okay? Everybody good? What's that called again?
Trinomial.
What kind of trinomial?
Quadratic.
I'm going to keep asking because
Wait, why
okay.
is it quadratic?
It's a quadratic because the highest degree is 2. Okay? Remember, you have constants. That's the degree of 0. Linear, degree of 1. Quadratic, degree of 2. Cubic, degree of 3. Okay? And that's really as high as you have to get. All right? 4 does have a name. 5 does have a name, but
Let's just not say that.
don't worry about it. Okay? Don't worry about it. Don't worry about it, sweetheart.
Don't worry about it. Don't worry
All
about
right.
it, sweetheart.
Yeah, what I
Now
said.
he's on an Invisalign commercial now.
All right. 3x times 2x.
6x squared.
6x squared. 3x times 4. 12x. Negative 5 times 2x. And negative 5 times 4. That will reduce. Those two are the same in the middle there. So 6x squared plus 2x minus 20. Okay? I'm glad you think they're fun because you're going to see them from now on a lot. Okay? In literally every math class you take. All right? Where did I get what now? Here? I have 12 here, 12 x's, and I'm taking away how many? 10. Okay, so 12 x's minus 10 x's, I'm left with 2 x's. Okay? You got to say it like that. Otherwise, people start saying, "Oh, that's 2x squared," because there's 2. No, no, we're not multiplying there. Okay? Any questions? All right. Trinomial times a binomial. Now, it doesn't matter. Yeah, it says use a table. You can.
Does it matter what order you put them in?
It doesn't matter. Okay? It doesn't matter. So I'm just going to do this one. Let's see how many more examples I got. Got that. Okay. We'll talk about this one. So I'm going to do this one both ways just to show you get the same answer. Okay? So we have x squared plus 2x minus 1 times 3x plus 4. Now, we are multiplying. Does it matter what order you multiply? No. So if you wanted to move this into the front, you can. It's okay. All right? But right now, I'm going to distribute how many different things? If this is in the front, how many am I going to distribute? 3. Okay? 3 of them. All right? So, x squared times 3x.
3x to the third.
X squared times 4.
4x squared.
Takes care of my x squared. Now I go to the 2x. 2x times 3x.
6x squared.
2x times 4.
8x.
Negative 1 times 3x.
Negative 3x.
Negative 1 times 4.
Negative 4.
All right, last part, negative 1 times 4. And then you add your like terms. So we have 3x to the third, 4x squared, and 6x squared is how many x squareds? 10x squareds. 8x minus 3x is 5x. And then minus 4. Okay? If you wanted to do the table way, I'm just going to say x and or 3x and 4. We would have x squared and 2x and negative 1. And you do it the same way. 3x times x squared is 3x cubed. 3x times 2x is 6x squared. 3x times negative 1 is negative 3x. 4 times x squared is 4x squared. 4 times 2x is 8x. 4 times negative 1 is negative 4. You add your like terms up, and you get the same thing. 3x to the third plus 10x squared plus 5x minus 4. Okay? Doesn't matter to me how you do it. Whichever way you like better. Everybody good? Okay? All right.
So that would be a cubic. What's the 4 one?
4-term polynomial. Remember, anything above 3, we're not really worried about either way. So it's a 4-term cubic. Okay? 1, 2, 3, 4 terms. It's a cubic. All right? We're going to skip the last one. It's doing the same thing. You're multiplying a trinomial times a binomial. This closure and multiplication. Closure. All that means is if you multiply a rational number by another rational number, what's your answer going to be? A rational number. So that's the same thing with polynomials. If you multiply a polynomial by another polynomial, you're not going to get something that's not a polynomial. Okay? Polynomials times polynomials equal polynomials. Everybody okay with that? That's all that's saying. Okay? So either way, you're going to get a polynomial. All right. Any questions about that? All right. Example 6. We are. That's a phone. It's a. Looks like a little roadrunner. Yeah, made out of.
It looks like a chicken.
It's a roadrunner made out of 2 rakes and a gas can and some stuff around the house. So, this is taking what we've learned and applying it to a real life problem. Okay, so a smartphone has a screen that has a width of x and a height that is 1.8 times the width. Okay, so again, that's talking about the what? The screen. That's not talking about the entire thing. It's just the screen. Okay, the outer dimensions on the phone are shown. So here's the outer dimensions. Okay, the screen itself is, what's the width again? Or what's the height, I should say? 1.8 times the width. Okay? The width is what? X. So, what here, that must be X, right? See the 1.8x, all right? That's this part, but again, we're just talking about, that's the screen. Okay? Everybody follow me so far? All right? So, what did they add? What's added on here on the outside? The 3. And for the height, what's been added? The 1. Write an expression for the portion of the phone that is not occupied by the screen. Assume that the phone is rectangular. Okay? So, we all know it's not actually rectangular because it's got rounded edges. Okay? But it says to assume it's rectangular. So, we're going to act like it's rectangle. And they want us to find the area of the part not occupied by the screen. So basically, we're trying to find everything that I'm not plugging in or shading in right now. Okay? I'm trying to find all the part that's not red. So you're going to have a lot of these problems. So get good at them. All right? So first, to find the area that's not shaded, we're going to find 2 things, and you're going to have a bunch of these. You're going to find the entire area, and then take away the parts you don't need, and that will leave you with the parts you need. Okay. So what's the area of the entire phone? 1.8 what? X plus 3 times x plus 1. That's the entire area, okay, the total area. So multiply that out. 1.8 times x times x is 1.8x squared. 1.8x times 1 is just 1.8x plus 3x plus 3. So 1.8x squared plus 4.8x plus 3. That's the total area, okay? I should put I'll put a little T down there for the total, okay? The area of the screen is what?
It would be 1.8x.
1.8x times x, which is 1.8x squared. What do we do with those 2 things? Subtract. Always subtract the smaller part away from the bigger part. So the bigger would be the total, okay? So we're going to say our final area is 1.8x squared plus 4.8x plus 3 minus 1.8x squared. Well, they just cancel. And so the area of the part that's not shaded is just 4.8x plus 3. Okay? Real life problem. It takes what we did yesterday or 3 days ago, okay? Adding and subtracting. It takes what we did today when we're distributing and combines it all together in a nice little word problem. Everybody good? Okay. Any questions? All right. I'm going to say have a great day and stay above the line.